How many integers between 100 and 999 inclusive have the property that some permutation of its digits is a multiple of 11 between 100 and 999? For example, both 121 and 211 have this property. First, we're going to find out how many multiples of 11 are between 100 and 99. So first, I know that there are 9 multiples of 11 between 11 and 99. And so the largest that 11 is going to get up to, like if we do 11 times 90, that's 990. That's going to be the largest multiple of 11 within that interval, 100 to 999 inclusive. So therefore, there are 90 multiples of 11 from 11 to 999. So the number of multiples of 11 between 100 and 999 is just 90 minus 9. So there are 81 multiples of 11 between 100 and 999. And now we just have to figure out how many different ways we can permute these 81 multiples of 11. I'm going to break this down into cases. Case 1 is going to be that the 3-digit number has 2 of the same digit in it. So for example, 121, 1 shows up twice. There are 3 ways we can permute the digits. So therefore, there are 3 permutations here. The exception comes from the numbers 110, 220, 330, all the way down to 990. The one permutation that's not going to work is, for example, if we took 110 and permuted it like this. Now that permutation is not a 3-digit number because 0 is in the hundreds place. So for all of these numbers, we're then not going to count these 9. So there are 9 of these permutations that won't count. Okay, so that's the exception there. The next case, case 2, is going to be if all the digits are different. So all different digits. So for example, 132, we could say there are 6 permutations here. But the issue with this here is if you know your divisibility rules, you'd know that the divisibility rule for 11 is I know something's divisible by 11 if I add the hundreds and the ones place and subtract by the tens place. If that's either 0 or 11, then I know it's divisible by 11. So that's 0, so I know that number is divisible by 11. However, what happens if I switch the hundreds in the ones place to 231? This number is then also a multiple of 11 because 1 plus 2 minus 3 is also 0. So when you switch the hundreds in the ones place, this is also a multiple of 11. Therefore, we'll have double counted since we can switch the ones in the hundreds place. So since we were double counting um, all of these um, all of these 3-digit numbers where all the digits are different, since you can just switch the ones in the hundreds place and you get another multiple of 11, then that's the equivalent of, we divide our 6 permutations by 2, it's the equivalent of 3 permutations each. And the exception here is going to be when there's a 0 in the tens place. And the way we figure out those numbers is we think of, so I know 0's got to be in the tens place. I think of 2 numbers that are going to add to 11. So 2 and 9 add to 11, thinking about our divisibility rules for 11. So this is one of them, and I keep going. So 3 plus 8 is 11, and I'm just going to see how many of these numbers we generate. So 407. Nothing's going to work for, yeah, so we're going to have, yeah, then 506, 605, 704, 803, and 902. So there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of these. So these 8 numbers, so when we do that, we're not going to count those. But we can also do this, 092. But if we look at here, this 902, we can also make those here. So we can make these same permutations from 902 and 209, 803 and 308. So we're double counting here, 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 and here. So we're just going to take these 038, 083, 047, 074, and then 056, 065. So these are the permutations we're not going to count, and there are 8 of these. And next we consider, what about the case where all the digits are the same? Well, if we think about multiples of 11, I know 110, 220, 330, 440, 550, 660, 770, 880, and 990. Now, if we compare those to where all digits are the same, so 111, 111, yeah, 111, 222, 333, we see that there's no way, like we pass these numbers when we add 11 to 110 and we add 11 to 220. So therefore, no 3-digit number where all 3 digits are the same will be a multiple of 11. So none of these we can see is going to be a multiple of 11. So now we can kind of sum it all up. So we have 81 multiples of 11, and we found that it's 3 permutations for each case. So all 81 multiples of 11, we're going to multiply by 3. And then we're going to subtract the 9 permutations that we found in the exception for case 1. So minus 9. And we're going to subtract the 8 numbers we found in the exception for case 2. So minus 8. So when you do that, we get 243 minus 17, which is 226. So there are 226 integers between 100 and 99 inclusive that have this property. So the answer is choice A.